Hey there, ladies and gentlemen. So we have been adding and subtracting fractions with like and unlike denominators, right? We've been modeling them with the pie eating contest. Y'all remember those? And then we did the algorithm off to the side. You remember we drew the little pies, and then did the algorithm off to the side. Okay. So today, what you're going to do is the actual step work for how to add and subtract fractions with unlike denominators. Alright, y'all know with the like denominators we add the numerators or subtract the numerators, and then we bring down the denominator, right? Y'all remember this? I should see shaking heads, right? The like denominator just comes down, and then you simplify, and then you bring the denominator down, you add or subtract the numerators, and then that would be your answer. And then if you need to make the fraction smaller, you would simplify the answer. Does everybody remember that? I should see some heads shaking. Good job. Alright, so step 1. This does have 6 steps, so go ahead and get your oohing and ahhing and awing out. Okay? Don't forget we're going to show some work over here. If you need to, do the folding thing again. So step 1 is I'm going to write the problem vertically. If not already done. Okay? So it's going to be 3/5 plus 1/2, and then 2/3 minus 1/6. Alright? So those are your new problems. Well, they're not new, but that's how you would write them. Okay? Step 2. You notice that the denominators are not the same. We got 5 and 2, 3 and 6. Everybody sees that, right? Good. So step 2, we're going to have to find a common denominator. For both fractions. Alright? Fraction number 1, fraction number 2. So I'm going to have to find a common denominator for 5 and 2. What do both of those numbers have in common? What number do both of those numbers have in common? Okay? We're going to use the least common multiple. Or LCM, that's how you'll hear me talk about it, to make the new denominator. Okay? So, we got 3/5 plus 1/2, and then 2/3 minus 1/6. So we're going to have to find a number that both of these denominators have in common. Okay? What number does 5 and 2 have in common? Okay? When I look at my multiples, I got 5, 10, 15, 20, 25, 30, right? Alright? And then I have 2. So if I do 5, 10, 15, 20, right? And then if I do 2, 2, 4, 6, 8. Oh, look, we got a 10 and a 10. Does everybody see that? 10 and 10. 2 times 5 happens to be 10, so it works out, right? So I've got 10 and 10. Okay? Now we've got 3 and 6. What do you know about 6? I heard somebody say it. 3 will go into 6. Good job. Okay, so did we find a common denominator for both of our numbers? Good job. Step 3. We're going to change the equivalent fractions original. Sorry. Don't write that. Original fractions into equivalent. That's where equivalent came from. Into equivalent fractions using the new denominator. Okay, so we got 3/5 plus 1/2, and we've already found this denominator, right? They both go into 10, and then we've got 2/3 minus 1/6. Again, we've already found these, right? Good job. So now I've got to make these equivalent, right? So y'all have heard me say using the power of 1, right? What I do to the bottom, I have to do to the top. So 5 times what is going to give me 10? Good job. 5 times 2. What I do to the bottom, I have to do to the top. So 3 times 2 is 6. Good job. Again, the power of 1, right? 2 times what gives me 5? I mean 10. 2 times what? 2 times 5. Good job. What I do to the bottom, I have to do to the top. And 5 times 1 is 5. Okay? Then on the other side, power of 1 again. 3 times what gives me 6? I heard somebody say it out there. 3 times 2. So 3 times 2 gives me 6. By the power of 1, what I do to the bottom, I have to do the top. 2 times 2 is 4. Good job. Now, do I have to do anything here? This is already 1/6, and I'm using 6 as my denominator, right? Good. So all I do is just move over that 1. Okay? So I'm going to show y'all. I'm going to move these in. All right? So there's 1. And then we have 2. Actually, let me zoom in some more. We have 1. Then 2. And then 3. Alright, so we're going to move to the second page if you don't have room on your next one, which I don't, and we're going to do step 4. Alright, again. Oops. My line got all messed up. Here, I'll put it over here. All right, step 4. I got my paper fixed now. Step 4. We're going to subtract or add, depending on the problem, the new numerators. Okay, so we've got 3 over 5 plus 1 over 2, which equals 6 over 10, and 5 over 10. And then on the other side, we've got 2/3 minus 1/6, which equals 4/6 minus 1/6. All right? So this says subtract or add, depending on the problem, the new numerators. So I've got 6 and 5. What is that? 6 and 5, 11. Good job. And then we got 4 and 1. 4 minus 1 is 3. Good job. Now, this problem here is no longer void. That is a voided problem now, because we're only working with this new denominator. All right? Because you can't compare apples to oranges. You can't compare apples to oranges. You have to compare apples, or you have to compare oranges. All right? Okay. Step 5. Oops. Step 5. Drop down the new denominator found in step 2. Okay? So we got 3/5 plus 1/2 equals 6 over 10 and 5 over 10. 11. We got 2/3 minus 1/6, which equals 4 over 6, 1/6, and we've got 3, right? So all we're going to do, remember, adding and subtracting fractions, the denominator stays the same. And unlike denominators, your denominator becomes the new denominator. All right? Okay. Step 6. Simplify if needed. Now, (11 over 10). What's wrong with 11 over 10? Did I hear somebody say it? Good job. 11 over 10 is an improper fraction. So I have to turn this into a mixed number. All right? I know 10 will go into 11 one time. I have 1 left. My denominator moves over. All right? And then we have 3 over 6. What do we know about 3 over 6? Good job. I know that 3 can go into 6 by the power of 1. If I divide both of these by 3, 3 divided by 3 is 1. 6 divided by 3 is half. You also should have known this from the fraction decimal conversions. All right? Good job. So, let me do this again. Okay, step 4. Step 5. Step 6. All right. Y'all ready for the examples? I knew you would be. All right, let's look at these examples. All right. So we've got 5/12 plus 1/3. Now look at your step 1. The problem is already written vertically for you, so you don't have to do that, right? Step 2 says I've got to find a common denominator for both fractions. We're going to use the least common multiple to make the new denominator. So I have, oh, did I hear somebody say it? Look at this, 3. Does 3 make 12? Sure does. So I don't even have to really work really hard, right? Oops, I shouldn't have done that yet. So the power of 1, 3 times what gives me 12? 4. Good job. So 1 times 4 is 4. So our new problem, I didn't have to do the power 1 here because this is a 12, right? Good job. So we've got 12 and 12, and when I move my 5 over and I multiplied by 4, I get 4. Good job. So my next step says, we've already done it. Change the equivalent, the original fraction, into its equivalent fraction, which we already did. And then step 4 says subtract or add, depending on the problem, and we have addition. Okay, and I'm adding the new numerators, so 5 and 4. So I've got 9. Step 5 says drop down the new denominator, so I've got 9 over 12. And then step 6 says simplify if needed. 9 and 12, is that the smallest that 9 and 12 will go? Is there any number that can go into 9 and 12? Do 9 and 12 any common factors? If you need to, remember this chart? Pull out this chart. What do 9 and 12, what colors do they have in common? See, I got a purple here and a purple here. What is purple? No, not purple. I'm sorry. That's blue. My bad. Sorry. What do they have in common? Good job. They're 3. 3 will go into both of those problems, right? Okay. Both of those numbers. 3 is a factor for both of those numbers. So, if I divide by 3, power 1, y'all heard me say that, right? If I divide by 3, 9 divided by 3 is 3. 12 divided by 3 is 4. So my answer is 3/4. Alright? Now, let's look at this one over here. Totally messed up this video, didn't I? Alright. Okay. So I got to find the multiple, right? So we've got them written in vertically. We've got to find the common denominator for both fractions. Step 2. We're going to use the least common multiple. So I got 4 and I got 7. So I got 4, 8, 12, 16, 20, 24, 28. I heard somebody say it. Wait, 7, 28. So let's figure out 7. 7, 14, 21, 28. So, one they have in common is 28. And it just so happens that 4 times 7 is 28. Good job. Now, if you can't find the least common multiple, you can always multiply your denominators. Now, the problem is, these denominators could get bigger. Alright? So then, by the power of 1, that was kind of funny. Found the new denominator, and then I'm going to change the original fractions into my equivalent fractions. So 4 times 7, what I do to the bottom, I have to do the top. 1 times 7 is 7. 7 times 4 is 28. What I do to the bottom, I have to do the top. 1 times 4 is 4. Good job. Now, what am I doing here? Because step 4 says subtract or add, depending on the problem, the new numerators. So I've got 7 and 4. 7 minus 4 is 3. Good job. And then what's my new denominator? 28. I got to drop down, right? So, then I have to ask myself, can I make 3 28s any smaller? Does 3 go into 28? No, it doesn't, because 9 times 3 is 27. So the smallest this fraction will get is 3 28s. Alright? So, these are your step-by-step adding and subtracting notes with your samples. And your we will start rotations after this lesson. I hope y'all have a great day. Bye.